Hi, good evening. So this is Sangeetha, Assistant Professor, Electronics and Communication Engineering Department, SNS College of Engineering. So in today's session, we are going to discuss about interfacing of motors. Okay. So first we will see that what is sensor and actuators. So sensor, in simple words, sensor is a device that listens to the physical environment and tells what happens. So each sensor is able to listen to a specific input. It may be a light, heat, motion, velocity, moisture, pressure, or anything in a variety of the other environmental phenomena. So next one is actuator. So actuator is a device that converts energy into movement. It could be a valve or motor. So next we will discuss the different types of actuators used in Arduino. What are the different types of motors? That is, actuator means electrical actuators. There are three types of motors can be connected with the Arduino. That is DC motor, servo motor, and stepper motor. So first we will discuss about DC motor. So DC motor is a direct current motor, is the most common type of motor. So DC motor normally have just two leads, one is positive and one is negative. So if we connect these two leads directly to a battery, the motor will work, that is motor will rotate. Suppose we want to switch the leads, if we want to switch the leads, the motor will rotate in opposite direction. So we can control the speed and direction of the motor. So there are some additional components required to connect the Arduino with the DC motor. So on Arduino board and the transistor PN 2222 transistor and 6 volt DC motor and 270 ohm resistor and 4.7 kilo ohm resistor and IN 4001 diode. So these are the components required to connect the motor with the Arduino board. So this is the connection details of Arduino with DC motor. That is in the Arduino board, the second pin is connected to the resistor and it is connected to the diode in series, and it is connected to the ground, and 8th pin is connected to the another resistor 4.7 kilo ohm. So it is connected and this is connected to the VCC. This is connected to the VCC. So this is the connection, the schematic diagram of Arduino with DC motor. And for controlling the DC motor, so in the first diagram, that is there are two leads as I said earlier. So if the 12 volt battery is connected, so if the positive is connected to the positive pin, that is 12 volt, and if the ground pin is connected to the ground volt, it is for clockwise connection and maximum speed. We can get the maximum speed. So the next one is, we want to control the speed. We can use PWM, that is pulse width modulation. So for clockwise direction and the controllable speed, we have to connect the output of PWM, that is the output from the PWM pin from Arduino is connected to the DC motor. It is for clockwise and controllable speed. So if we change the connection, that is 0 to 12 volt, we change the connection, it is for anti-clockwise direction and the maximum speed. Suppose we want to control the speed, the PWM output is connected to the negative pin. Okay, so this is for controlling the speed of DC motor. So how to control DC motor using Arduino, that is PWM. So controlling DC motor includes two factors, as I already said, speed and direction. So the Arduino can generate the PWM signal. However, the PWM signal has low voltage and low current, so we cannot use it to control the DC motor. So we need extra hardware in between Arduino and DC motor. So the driver does two works. So it amplifies the PWM signal from Arduino for speed control, and it receives the control signal from Arduino to swap the pole of power supply, that is for direction control. So the Arduino, the PWM is connected through the driver to the DC motor. So L298N, it is the motor driver. That is, it is simple to control the speed of the DC motor by generating a PWM signal to the ENA pin of L298N. So we can connect to this by convert an Arduino pin to ENA of L298N. So it can generate PWM signal to ENA pin by using analog write, using the instruction analog write function. So analog write within bracket ENA underscore pin, that is for speed, comma speed, that is for, it is a speed value from 0 to 255. So the speed is a value between 0 and 255. If the speed is 0, the motor stops. If the speed is 255, the motor spins at a maximum. So next one is how it can be controlled, how the direction can be controlled via L298N driver. The spinning direction of a motor can be controlled by applying a logic high or low to IN1 and IN2 pins. So if we connect the IN pin low and I2 pin low, motor A stops. So before that I have to that is L298N driver. Using L298 driver, there are maximum 2 motors can be connected. Okay. So next next is to control the direction. So if both pins are low, the motor stops, and if both pins are high, the motor stops. Okay, if the INA pin is high and the IN2 pin is low, the motor spins at clockwise, and if the IN1 pin is low, connected to low, and IN2 pin is connected to high, the motor spins at anti-clockwise. So this is the control logic to control the direction of the DC motor. So this is the code for DC motor. So the DC motor is connected to pin number 9, and pin mode, first we have to select the modes, that is motor pin and output, and we have to set the baud rate and set the serial port, and speed is serial port, and we have to connect the analog, that is we have to write the analog write signal, that is analog write motor pin comma speed. So this is the code for connecting the Arduino with the DC motor. Okay, thank you.